Hi. So let's have a look at how we can code an option strategy from scratch. Once you have logged into your Algobulls account, you can head over here to Python build. And then if you want to look at some ready templates that we have, then you can choose this. In case you want to start from scratch, then you can choose this section here. And once you have created a single strategy or you have created multiple strategies and you want to have a look at those, then you can head over here to my coded strategies. To have a look at the documentation about how a strategy is created, what is the structure of a strategy, we can head over here to Google. We can search for algo trading. This page will open. I'm scrolling down here to the home page. This will take me to GitHub. And here I have a link, which is the documentation page. And here I can have a look at the structure of a strategy, even browse this whole tutorial, have a look at this whole website. So I have a handy search here. Once you are familiar with this website, you can use this search bar. For now, we'll move on to strategies. Let's have a look at the general strategy guide. I'm moving here to the flow of a strategy. This is the flow of a strategy. We'll have to create a method called as init, another method called as initialize, and then we will have four methods, two for entry and two for exit. This method is for selecting instruments for exit and then actually exiting those instruments. And this method is for selecting instruments for entry and then actually entering the position for those strategy for those instruments. I'm sorry. So init, initialize, and these four methods are our important methods that we are going to code. You can have a look at the way regular strategies are coded as well as option strategies are coded. If you come here, you can have a look at the structure of the ready templates that we already have. So you can open any one of these and you can have a look at the ready templates. For now, let's move on to this section, choose from scratch. Let's click on over here. We can maximize this code editor. I'm just going to do that. And we can start coding from here. There are ways to accept parameters from outside and then run the strategy as per those parameters. To do that, you'll have to come here, which is tweak strategy, which should give me a message that I have to save my strategy first. So if I click here, yes, it says save my strategy. I'll do this just that. Let me just code a few lines and then let me save the strategy. Once I save it, I'll give a new name here, which suits, and then we'll also have a look at this pane, which will help us take parameters or values from outside, and then we can use that to run our strategy. So let's have a look at the basic structure. Okay, so here let's have a look at the basic structure of a strategy, and let's code for option strategy. So I'm importing a few things from the PyAlgo trading package, one of which is my parent class. It hides a lot of advanced functionality which we can use readily in our strategy that makes it easier for the strategist to focus on what he wants to do and leave the heavy lifting to the parent class. So that's a good thing. I'm naming my strategy to something. Once I save it, I can use this same name here at the top. The init method is nothing but a call to the parent method. Initialize again here is a call to the parent method. Then we have two entry methods. One is where we'll actually do the selection and one will actually place the order. And two exit methods, whichever we have placed the order for, we will get them here and then we decide whether we have an opposite signal for them. And then we go ahead and exit those instruments. So the return type here is two lists. One is the list of instruments for which we want to place the order, and the other is extra information or metadata about that instrument. Example, we could say that we want to buy the instrument, or we could say we want to sell the instrument. So whatever we wish to do, that extra data we can give in the second list. Then we actually come here Here we will create the order object and we'll return that to the algobools engine. Then we come to the exit. The same thing happens here. We look for a signal and then we do two things. We first select those instruments and then we add extra information or metadata about those instruments. And then we go ahead and exit those positions for those instruments. So this is what the general structure would be for even a non-option strategy. In this case, we'll be coding for an option strategy. So these are the generic methods that we have to use and we can code our strategy. So let's go ahead and understand the parameters that we can set up for option straddle, wherein we will have two legs, one for call, one for put. We will set up both of them as sell and we will select for now an ATM instrument only, which is at the money instrument only for both the legs. So we need to set up those parameters in init. Now, Python build is advanced in a way such that we can use it for running backtesting for multiple months, multiple days, and we can even have a look at the performance that our strategy is exhibiting or displaying. So we can code it in such a way and we can execute it in such a way and have a look at the performance that the strategy is giving. So that is the power. In which case, we might be running our strategy for multiple days. So herein lies the difference between init and initialize. When the strategy starts, init is executed just once, but for every new day that the strategy is continuing to execute, initialize gets called again and again. So any data structures that we will be using, we can clean those data structures here at the start of the new day and then continue with our four methods for the day. We can set up a candle size, let's say 1 minute, let's say 5 minutes, let's say 10 minutes. So every minute or every 5 minutes or 10 minutes, depending on your candle size, these four methods will get called. So let's assume we set up a 15-minute candle. So every 15 minutes, exits will get called, and immediately after that, entries will be called. So this is how the execution will go. The same explanation is given here. Exits get called first, you can see here, and then entries get called. This will keep happening for any candle size that we set up. So we are going to do that. So let's have a look at the parameters that we will need for options straddle. So these are the parameters. We have two legs. So these four parameters are for the first leg. These four parameters are for the second leg. We have the transaction type, which can be buy or sell. We have the trading symbol, which can be call or put. We can decide on the strike direction, which is at the money, out of the money, or in the money. And we can also decide the number of strikes away which we want to select for that particular call or put. Right now, we want to select at the money, so we are not navigating any number of strikes away. That's why this value is 0 for now. The same we are repeating for the second leg, but in this case, we will be taking a put, which is a PE instrument, and we will be selling it off just like the previous one. We'll set up the map where we can translate these values into the actual values that we want. We currently support four types of expiry dates, which is the weekly current, weekly next, the monthly current, and the monthly next. So how many expiry dates should your strategy support? So here I'm keeping the value as 1. So currently this will only support weekly current instruments, the instruments which are going to expire in this week. Also, I'm picking up, rather, I'm setting another variable called as instruments run for the day because once I enter the position, I don't want to do anything else for the rest of the day and let the market end beside the exit for both the legs. In other words, I am not going to code anything in the exits. I'm going to leave them as it is. I'm just going to set up my instruments and I'm going to place the orders for both the legs. And then I'll keep checking. If I have already placed the orders, then I don't want to go ahead. So I'm going to use this variable to check that, because every 15 minutes, these four methods will be called again and again, and I don't want to keep placing orders again and again. So this is just a flag or a variable which I can use to stop placing any more orders once the first set of orders have been placed. So I'm going to use this for that. Let's have a look at initialize next. So the only cleanup that I'm doing is I'm resetting my instruments variable to a blank list, such that at the next day, I'm again able to place my two legs. I'm again able to place two orders for my two legs and continue for that day. So for if you're running the strategies for multiple days, then at the start of every day, I want to set this to a blank list such that I can continue for the next day and so on. Okay, now let's have a look at selecting instruments for entry. Since I want to return two lists, one having the list of instruments and one having the metadata about those instruments, about the details of the action that I want to take for that instrument, I'm going to set up two lists. One is selected instruments and one is the meta. And I'm going to ensure that I return these two lists here. So my logic goes between these two lines, and let's code to set up our two legs and then make sure that those are passed here in strategy enter position, and then we are able to place the orders for our two legs. So let's set up the logic here. Since this bucket is a loop, because I can have multiple instruments for which I'm trying to check for favorable signals and place the orders, I'll have to take a loop here for each instrument in instruments bucket. I'll have to do that. Also, I'm going to ensure that the orders are placed only once. So I'm going to check that if this current instrument is not in the variable which I have set up, which is instruments done for the day, if it is not here, then I'm going to add it into the list so that it does not get executed again. And then I'm going to go ahead and set up all the details required for that leg. So I'm going to say self dot instruments done for the day dot append, and I'm going to add my instrument here. This ensures that in the next candle, let's say we set up for 15 minutes, then the next candle, when we come back to this method for selecting instruments for entry, we ensure that this loop does not get executed. Rather, we will come inside the loop, but we will check the if condition and we will ignore everything. So that is what we are going to do. Now, I need to set up my instruments for call and put. One of the things that I'll be needing for that is the last traded price for my instrument. So I'm going to take up a variable called as LTP, and I'm going to use a method called get LTP, which is the last traded price for this instrument. So I'm going to set up my LTP here. And the next step that I want to do is fetch all the instruments which are possible for call and fetch all the instruments which are possible for put. And depending on this LTP, I want to select the add the money instrument and then set it up for order placement. So this is what I want to do here. For this, I'm going to create a small method, which is not a mandatory method. It is something that a developer can do to manage his code. So I'm going to do the same. And then let's add a smaller method which will help us set up our instruments. So let's go ahead and do that. This is my method for setting up my child instruments, which is call and put. So the instrument that I have here, I call it my base instrument because from this base instrument, I'm going to extract my call and put instruments. Then whether I want to set up the instruments for call or put, So I'm going to pass that trading symbol here. The current close is the last traded price, which we have already created here. We have it ready. We are just going to pass it. And the direction as of now is exact. In case that the current close is somewhere above 0.5 or below 0.5, then the ATM instrument gets selected in that manner. So if the current close is above 0.5, the ATM instrument gets selected as 1. And if it is below 0.5, then the ATM instrument gets selected as 0. But if we don't want that to happen, regardless of whether the LTP is above the middle or below the middle, regardless of that, we always want the ATM to be selected as the lower value. Then instead of exact, we'll have to say round down, or else we'll have to say round up if we want to disregard the LTP values decimal places. But right now, I don't want to do anything like that. If the value is above zero point 0.5, let it select something close to 1. If it's below zero point 0.5, let it select something close to 0. I don't want to override that with a round up or a round down. So right now the direction is just exact. I'm not going to do anything here. Now, I also want to set up the number of expiry dates that I am going to allow. So I have it here, which we have already set up as 1. So I'm going to get my expiry dates here. And then for each of those expiry dates, I'm going to set up my instruments. Currently, we are setting this to 1. So this loop will be run only once and it will set up the instruments for weekly current only. Instruments that get expired in the current week, for those we are setting up our instruments. So let's go ahead and do that. So let's set up. These are my 2 lines of setup for call and put. So I'm passing my instrument, which becomes the base instrument here. And then I say I want to set up for calls first with the last traded price as given here. And then I do the same thing again for the same instrument, but this time I want to set up puts. Now what happens is this tells the parent class that I want to set up my instruments. And the parent class does a lot of heavy lifting and it fetches those instruments of calls, fetches those instruments of puts, and sets them up for me for later use. Now, the later use in our case is where we select an ATM instrument and then place the order for that. But in the case of in the money, that is ITM, or out of the money, OTM, I can still use those instruments also by giving the number of strikes away as something else and the strike direction as ITM or OTM. And then I'm repeating, just giving the number of strikes as 3 away or 4 away, and then we can choose those also. So this helps me set up, and then I can pick up my child instrument, that is my calls and puts, from these data structures and go ahead. So the parent class helps me to do that. I just have to call the method of the parent class and set up my instruments. So let's go ahead, and for both of the legs, let's uh, what can we say? Let's set up the instruments that we want to select and the metadata for them. So let's go ahead and do that right now. So I'll set up a leg list for both of my legs. This is my leg list. For leg 1, whatever I need, which is the suffix, the direction, the number of strikes, and the type. Same for leg 2. And then I will loop over them and I will try to bring all the data together that I want to add into both my lists. So let me bring all of that data together here. Just like the way that I have used a method to bring my options instruments, I'm going to use another method to bring my child instruments, which is my calls and puts. So let me create another method here, which gives me my ATM instrument for leg 1 and my ATM instrument for leg 2. In one case, it will be call. In one case, it will be put. So let me set up this method and let's have a look at that one also. Once we have that instrument, we are going to add it in our first list. And in the second list, we are going to add additional information, one of which is the instrument for which I am doing all of this, and the other is the action, whether I want to buy or sell. In our case, we are using both our legs for sell, but this is a generic method. In case you want to change it to buy and have a look at the performance or the changes that your strategy exhibits, you can go ahead and do that here. So let's set up this method now. I'll add my method here. This is my base instrument, whether it's a call or a put. The strike direction, in this case, our case, we are selecting at the money. So strike direction is 0, which is ATM. ATM is 1. ATM is 1. Yes, strike direction is 1. So ATM, and the number of strikes will be 0 here. So number of strikes will be 0. I have only one allowed expiry date, which is weekly current. So I'm going to do that, and I'm going to pass this to my parent method, which is get options instrument with strike direction, and it will directly help me to select one of those child instruments based on the LTP which I've already set up. So my ATM instrument I'm going to get here. Again, if I change the direction and I change the number of strikes, then I'll be able to select in the money or out of the money instruments based on that. So as simple as that, I should be able to get my child instrument. Now, since I'm saying ATM, I know I'm going to get one child instrument. But depending on what you want to do, you can have multiple child instruments also. So let's have a look at that in another strategy, perhaps. But in here, this is a simple strategy where we are just setting up two legs. So I'm going to do that. Once this is done, I'm passing both my lists to the algorithm engine, and the algorithm engine will now call enter position for each of those instruments which are selected. So as we know, we have selected one call, one put. So this gets called twice, once for a call instrument and once for a put instrument. Let's place the orders and let's return those orders back to the code. So this is our next step. Let's place the orders now. So I can use a method called as order regular. In that, I need to pass the call or the put that I'm going to try to place the order on. The action, in this case, the action can be sell because it's a straddle strategy. So the action which we had passed from above, the quantity, which is number of lots into lot size. And then once the order is placed, we return that to the core. So as simple as that, we just use the built-in method given by the core, which is order regular, and we try to place the order for that. Since we don't want to exit, everything will be at market exits. We are not going to code these two methods, and this is ready for us. We can just go ahead and set up, rather save the strategy first, and then we set up all the additional parameters that we want to do over here. So let me go ahead and say save. So that's it. I'll copy this. So that's done. And now I can, since I've set up my default values, I can directly go to this tweak strategy, and I should be able to select my base instrument, which in our case is an index. We can try with, let's say, Nifty Bank first. You can also have Nifty 50 here or Fin Service. So I'll try with Nifty Bank. I'm taking the candle size as 15 minutes. The rest of the parameters, I'm not touching them right now. We need to add our strategy parameters here in case we are looking to tweak our strategy with outside values. But right now we have set our values. So I'm just saying save. Yes, I've confirmed. And now let me go ahead and try to save and start. We'll also have a look at any errors that this strategy tells us, or if it executes, then let's have a look at the stats. So I'm changing my date to, let's say, 1st Jan 9:15. Sorry, 1st December 9:15 till, let's take a shorter period. Let's say 11th December till 5:20, 5:30, 5:20. Let's have go at 5:20. Okay. I'm taking my number of lots as 2. The rest I'm not touching. PNL tracker, I'm switching it off for now. You can have a look at all the configuration that it takes automatically, plus the one that we have set, which is our candle and the instrument which we are working on. Let's say execute. If there are any errors here, let's have a look at that too. Or else if it gets executed properly, then let's have a look at the stats. So the strategy has stopped. Let's have a look at the data. Yes, so some orders have been placed. I can look at the timeline here. So we have the orders placed. If you want to have a look at the bare bones logs, then we have those logs here. You can even download these logs from here. If I go back to the analytics, then I'm able to see my returns here. Right now, this strategy is making a loss. Maybe I'll have to select a different range of dates to get good returns. We have the number of wins, the number of losses, and quite a few other stats here. If you scroll down, you can have a look at the different metrics, stats. This will help you to gauge the performance of your strategy and then tweak it as required. So this is how you can code an option strategy. To understand more, to learn more, have a look at the ready templates given here. You can have a look at how they are coded. We also have the strategy structure, the Jupyter notebooks, where you can directly try these strategies and understand more about them. We also have a list of parameters and other things. So the documentation should be a good, helpful guide for you to go ahead. You also have the ready templates given here. So let me go back to Python build. I can come here, explore our ready templates. We have the option strategy here. The one which we have created is similar to this one, having no exits, which is here. And we have coded the entry as shown here. So we also have option straddle as a ready template. There are more ready templates here. You can have a look at US based strategies, non-option strategies. These are some of the US based strategies. You can even have a look at these. So that's all about coding from scratch and then ensuring that you are able to look at the logs, look at the stats, and understand and gauge the performance of the strategy. Yep. Thanks.